Welcome back. This is Jeremy at Hilt's Machine Works, and today I'm trying out a 5C Collet Chuck that is going to go on my small lathe, my Logan 922, which is an 11-inch swing lathe. And it can take 5C collets, but it's hard to find the adapter piece because mine's an earlier model. So it's kind of stuck going with a Collet Chuck here that doesn't require a drawbar. And what it is a 5C collet can fit down in there, and you can use a wrench, like a chuck wrench style, to engage the collet. And this is an imported one. It is from Bostar. I couldn't really justify getting a Bison and spending more on the occasional use 5C collet chuck than I did on the whole lathe. So we're just examining it here right out of the box, and what I found is obviously this is a really crummy finish that was left from the factory, but it doesn't really matter because you have to, and I'm going to show you this, we're going to have to put this in the lathe, and we're going to true this surface, and then turn this diameter down so that it has a really good engagement with the back of the collet chuck. And I'm going to shoot for like a 1/2 thousandths clearance, so that it really sits in there nice. That's going to be important for the concentricity and the whole reason of using collets. You know, they can hold a very high tolerance. So we will do that on the machine. That will true this. This is the semi-finished adapter plate, and we will true that to the machine so that everything is running very nice. And you'll have to excuse me, my 3D printer is printing off some stuff right now. I've been making some little AXA tool holders. You can see how they go in there. But anyhow, here's one of the problems I see. I'm going to walk over to the Logan now and show you an issue that I'm going to have. Okay, so here is the spindle nose on the Logan 922. And you can see I have a 3D printed tool to help lock the bull gear so that we're not breaking teeth off down on the counter shaft or anything like that for the back gear assembly when we're removing chucks and whatnot. And you can get these on eBay for pretty cheap, or you can find the files many times and print them yourself if you have a 3D printer. But the issue that I'm having here, well, number one, Logan had a proprietary diameter here feature on their spindles, where on many of the Logans, and I've explained this in my other video using my wall hopper head to adapt my faceplate on my larger Logan, you need to usually open up the back of the adapter plate or the faceplate or whatever it is you're working on to be able to have clearance over this diameter. Now, with the Bostar kit, it's already opened up enough that you don't need that. And I'm not really a big fan of this because, and really you should oil this when you put the chuck on or anything threaded on. I'm trying to do it one-handed with the phone. But it has clearance over it and it comes up against the shoulder. But what I don't like about that is I like to run, even though they say it's not necessary, a very, very close fit from this bore here to this diameter here. I like to run like a 1/2 thousandths fit, just like I do on the, or what we're going to do on this side. And I just like that because I think that as something's threaded on, and if it doesn't have a really close engagement here, in my mind, there's a potential, of course it goes this way, but there's a potential that under forces or whatever, you could get some kind of a rock potential in there. Personally, that's what I like to do. Obviously, in this case, I can't help it because I've already opened it up enough. However, you can see that this has a long way in here before the thread starts. So when you thread this on, and again, if I was doing this for real, I would put some oil on the threads. But when you get this on, you're not getting a lot of thread engagement inside. And I really, really don't like that. Number one, because you have an excess amount of overhang from, from the back, the semi-finished adapter plate to where the Collet Chuck even begins, or your chuck, or whatever it is you would have mounted to this. It has excessive overhang that we don't have to have, and you don't have as much engagement. So that causes an issue. So what you might say is, well, all you have to do, and usually guys put a board down or something so you don't end up being Basketball Jones and smashing that right down on the ways. But what you might think is, oh, well, just skim some of this off or thread it on the other way. But if you thread it on the other way first, you no longer have the clearance to come over here and up against the shoulder, so you're not really going to have it true. And you might say, well, just put it in a 3-jaw chuck or even a 4-jaw chuck up against the chuck and then face it off. Well, let's go back to the granite table, and I want to look at something that would bother me about doing that. We are back here at the granite table, and what I've done is I have very lightly cleaned what would be the mounting side of the Collet Chuck, and made sure there were no burrs or anything there, and just kind of seated it onto the granite. And I've come over here with my last word indicator where I have a 0 set. And what we're going to see is these surfaces are not parallel. In other words, the part you can't see here that's on the granite that seats into here, the part that we have to face off when it's on the machine, is not currently parallel with this surface, which seats up against the larger diameter of the spindle. And you see from here to here is pretty darn good. I mean, it's less than a 0.5 thousandths. We're talking a couple of tenths. It's more accurate really than this indicator can do. However, when we move to here, we see we're at +1. And when we're here, we're at -1. So we are about 2 thousandths off, or 1.5 thousandths off, 15 to 20 tenths off on parallelism across this way. This way was all right. And so if I took this as it sits right now, seated it up against in my chuck on my other machine, or even on the small Logan machine, and I ran an indicator right here, I would find out that it's not parallel with this, and therefore I don't want to face this thing off without it being parallel to this, and then flip it around and put it on the machine and then face it off again. Would it come out right? Okay, sure, it would be parallel here when I cut it on this side, then they would be parallel again, but I don't know if that would be true to the imaginary line if you was thinking concentricity and everything going through here, or if I'd end up having a slight, issue here with it not being concentric to the bore. That's my concern. So what I'm going to do is I'm going to put this on the machine. We're going to thread this onto the spindle, and what we're going to do is we are going to face this off here. We're going to skim cut this so that this surface here is now parallel with this surface here, and it will be on the spindle, so we know any issues with concentricity or anything like that are not going to be taking place. It's going to be mounted on the spindle. We're going to face this off. Then I'm going to take this, and I'm actually going to put it down on my Bridgeport milling machine with the freshly cut surface down, where we know it'll then be parallel from that surface to this surface. And I'm going to fly cut this and remove the material. We'll go over and measure it, and we'll write all that down so you can see. And we'll bring this down to where we want it, knowing that it still is going to remain parallel to this side. Then we will reinstall it on the lathe. And we will go back through, skim cut this again, skim cut this, and then turn down this OD so we have that 1/2 thousandths fit that we're shooting for in here. Then this is the only way in my mind that I am going to be completely confident that everything is done right and comes out right. If you have another way of doing it, or you think this is wrong, you can go ahead and tell me in the comments. Maybe you have a better idea. But I know if I do it this way, it will be perfect when it goes out. And I can trust that as long as this piece was made correctly, we're going to have a very nice Collet Chuck. And we'll be able to test that when we're done. So let's get started. I'm going to put this back on the 922, and we're going to take that initial skim cut here. But first, I'm going to use some Dykem on here, and we're going to find the high spot and mark it just so I know when I go back to the lathe where that high spot is. Back at the lathe, I just took some Sharpies instead of Dykem and marked the high area. And I have come in, not sure if you can see this, but I have very, very lightly touched, just skimmed with this sharp high-speed steel tool, and I've set a 0. What we're going to do is we're going to face out. So we know that it was about a 2 to 2.5 thousandths problem that we were encountering on parallelism over there, and that's evidenced by marked by the high side. How, remember, one side was raised up a little bit. And so what I'm going to do here is I don't have a digital readout on this lathe, so I've set up a brown and sharp indicator, travel indicator, and I'm going to move over just enough, now close to 4 thousandths I'll move. And what I'm going to do is I will lock the carriage. And I'm just right about at 4 thousandths. And now I have used an acid brush to put very light bit of cutting oil around the part. And we're going to face out. And I have a very fine feed because I'd like to have a good surface finish here. You can see that we're just barely, we're cleaning up all around, but we're just skimming it. Okay, we're back at the granite table, and we are much better off than we were. We're right at 0 there. We're less than a half here. We're at 0 here. And we're just before a half there. So we are within a 1/2 thousandths now instead of 2. And I'm very happy with that. So let's go to the next step, and we're going to start facing this off. Okay, so what I found is from the shoulder here out to where the thread stops is about 375 thousandths. That's what I want for clearance. It actually is a little bit less than that, but I want a little bit more clearance. So I'm going to give myself 375 thousandths from there to where the thread begins. The overall length is 1 inch and 85 thousandths, give or take, just with a rough caliper reading. The counterbore on the new part is 575 thousandths before I get to the threads. So we are going to come over to the mill, and you can see here it's about 575 thousandths to the threads. So what we're going to do is we're going to take 200 thousandths off the top, and we'll rough it a little bit, and then we'll take a nice finish cut over it when we're finished. And then we will put it back on the lathe. We'll no longer have the maximum overhang, and we'll have better thread engagement I'm gonna dust that face again. We will dust the other face on that side, and we'll turn the diameter down for that 1/2 thousandths fit. And I have put some washers underneath these clamps so that I know I'm pushing down on the surface we faced. And I've gone around here, and we are the same as we were on the granite table. We're about a 1/2 thousandths out, which is this claimed to have 8/10, to be accurate with an 8/10 of total indicator runout. So if I'm getting half or less as we go through this, I'm happy with it. All right, so what I'm doing here is I am taking a roughing end mill, and I'm just taking small cuts, 25 thousandths passes, to wear this thing down close to the finished size. And then I'm going to fly cut with my finished cut, probably the last 10 thousandths. And I think this is going to come out very, very nice. Take some light cuts, work our way down. Have patience. Okay, you can stop. Okay, raise her up another 25. Okay. Let's fly cut the last 10 thousandths off. All right, I didn't get the finish really that I wanted, or as nice as I wanted, but let's check her out. 0 there, 0 there, 0 there, and just about a half here. So I'm happy. Like I said, this thing brand new, only claims to have 8/10 of an accuracy limit. So when we're at or just hovering around a half, I'm happy with that. Now, what I'm gonna do is now we're gonna throw it in my 3-jaw chuck on my big lathe just to break the edges here, because that doesn't matter on parallelism or anything. I'm not concerned about that. So we'll just touch it up real quick. Then we're gonna go back into the small lathe. Okay, and to check it again on the granite table, just for fun, we get 0, we get about a +1/2, just under +1/2, and right at 0. So again, we're about a 1/2 thousandths off, which is acceptable for what I'm doing. All right, we're back on the Logan 922, and I have hand ground a tool here that I probably wouldn't use generally for turning. However, it's going to allow me to get right down into here, to face this surface off, come back, face this off, and you know, bring it in nice in there. Be able to reach in without anything hitting or anything like that. So let's go ahead and do it. Here we go. All right, I really like the way this is coming out. So we're down to our final operation. This has been faced, this has been faced. It's all running nice and true now to the machine. And I've checked with a depth mic from here to here. I'm where I want to be to fit into the recess over there. I have taken my measurement of the ID of the recess here, which I found to be 3 inches, 741 thousandths of an inch. And now we're going to go back over here where we have about 104 thousandths to take off. And I'm going to go easy because this is a really strange tool. It's not really proper tool geometry to be taking bigger cuts. So I'll whittle my way down. Not sure how much of this I'm going to be able to show on the camera just because these are such short cuts. But we will get this going and we'll have just that nice snug fit to go into the back of the Collet Chuck. We'll put our bolts through and it will be ready to use. Okay, I am now very, very close. And what I'm doing now is I'm going to polish this down. And I'm going to keep trying to hand fit this on there until I can get it so that it's a really nice fit. The moment of truth is here. I'm happy with this. I've cleaned it extremely well. I've cleaned this well. What I'm going to do now is I'm going to line these up. I'm going to put a little tiny bit of blue Loctite on each of the threaded holes. And we are going to assemble it. This is going to come out very, very nice. All right, so I'm having to tap this down just a little bit because it's such a nice fit. Holes are lined up. Let's turn her over. Flipped her over, tighten these down. I've got it on the machine. It's looking good. Let's put an indicator in here to see what it shows at the taper where the 5C collet goes in. Okay, the indicator is in. It is set to 0. Now let's bring around a full revolution. I'm showing right within a half from my angle of looking at the indicator. Hopefully it's coming in good on the video. This thing only claimed to be good within 0.8. And I think it's better than that with this indicator. So I'm very happy. Hope you enjoyed watching the video. One thing I will say now that I've got this on though is I wish I would turn this OD down to match this. I don't like the look of that. But now that it's here, I might be able to reach a tool in here and do something now. I don't know, I'll probably just leave it. But hope you enjoyed watching. And I think this is probably about the best way you can do this if you're gonna put on a Collet Chuck to make sure everything comes out very nice. Let me know in the comments anything you would have done differently. Thanks for watching, please subscribe.